Okay, good afternoon, all of you. So, today our topic is application of derivative, and in that chapter, you have a very important chapter that is called tangent and normal. And this is also common chapter of calculus and geometry. So, always you are actually concerned about some calculus point of view about a point. So, actually, one dimensional calculus related to some analysis of functional domain, range, and also limit, continuity, differentiability. So this is one of the significance of derivative, that dy dx represents the slope of the tangent of the curve. So if y equal to fx be an equation of a curve, at a point P on the curve, the value of dy dx, if defined, if it exists, you know that the derivative not always exists on the curve, because if the curve has a sharp point or corner point, then the derivative doesn't exist and gives the slope of the tangent of the curve at that point P. So it is another application of derivative. So sometimes this is the significant, this is called significance of derivative. So what is the significance of derivative? The slope of the tangent at that point, and this is said to be the slope of the curve at the point P. Suppose in the diagram P is the point x1 y1, okay, and at that point you see there is a tangent, okay. So what is the equation of the tangent? Tangent is a straight line, it passes through x1 y1, and you know that the equation of the straight line passes through x1 y1 and having slope m can be written as y minus y1 equal to m into x minus x1. So m is your nothing but your slope of the tangent at x1 y1, dy dx at x1 y1. So you need to find out the dy dx at x1 y1, then just you write this equation. This is the equation of the tangent. So it is a very simple equation. It is already known to everybody. In class 11 you have learned that what is the equation of the straight line. So using that you can write the equation of the tangent. So this is the equation of the tangent, and the line perpendicular to the tangent, the line perpendicular to the tangent is called the normal to the curve, normal to the curve. And you see here dy dx is, you have to evaluate dy dx at x1 y1. So you have evaluated, and how will you get the value of the normal? Because you know if these two lines tangents and normal are perpendicular, you can easily substitute the condition of perpendicularity m1 m2 equal to -1, and that gives you the value of the slope of the normal. So slope of the normal will be given by -1 by m. So -1 by m, that is -1 by dy dx, okay. There will be a negative sign because at x1 y1 definitely you have to calculate the derivative at x1 y1. So equation of normal at point P x1 y1 is given by this equation, y minus y1 equal to -1 by dy dx x1 y1. Just you are replacing, you are writing the same equation, this equation you are writing, but instead of m you are writing -1 by m, because normal is perpendicular to the tangent. And you know that before we going to the concept of tangent, you know the tangent is the limiting case of the chord, okay, because you have a curve and this is the chord of that curve, and this is the limiting case of the tangent. If you change it, it will touch the curve at one point. So this is the limiting case of, if p and q, if pq tends to 0, actually this is the limiting case of the tangent, is a limiting case of the chord, okay. So this is the equation of the tangent, and this is the equation of the normal at x1 y1. So let us solve some problems on that. First let us have a very simple example. Find the equation of the tangent at y equal to e to the power x exponential at x equal to 0, okay. So at x equal to 0. So what is your first thing? First you have to differentiate with respect to x. So you see dy dx is equal to e to the power x, derivative of exponential function is exponential function, and if you substitute x equal to 0, so y equal to 1, so the point is 0 1. Actually you look at that in the graph, the point is 0 1. So because it is mentioned at x equal to 0, so x equal to 0 is, if you substitute in the curve, you will get the value of y. So you naturally get the value of the point, the coordinate of the point where you have to draw the tangent. In this case, suppose x1 y1 is the point. So look at that, x1 y1 satisfies the curve also, satisfies the equation of the curve also. So if it is y equal to fx be the curve, then as x1 y1, at x1 y1 you are drawing the tangent, so it will be satisfied by the curve also. So this is one of the relation, because the tangent point, that is x1 y1, must satisfy the curve also, that the point lies on the tangent as well as on the curve. So that is why the concept is here. So the point is 0 1 because you are getting the y value by substituting, and dy dx, you got the value of dy dx at that point, and simply you write the equation y minus y1 equal to m into x minus y1 because your m is 1. So you get the tangent at 0 1. Okay. Similarly, next I will discuss another problem to make you understand. Find the equation of all straight lines which are tangent to the curve this. So you have to draw the tangent of this curve which are parallel to the line this. So this is a new concept to you, parallel to the line this. So let us first differentiate this. So what is the differentiation of 1 by x minus 1? That will be minus 1 by x minus 1 whole square, that is the derivative. Okay. And if you substitute, and this is your derivative. Okay. And what is the slope of the given line? What is the slope of the given line? The slope of the given line is minus 1. You look at that, the slope of the given line is minus 1. Okay. And let at x1 y1, suppose the tangent at x1 y1 is x1 minus 1 whole square, and the slope of the tangent is x plus y equal to 0. Slope of this line is y equal to minus x. So slope of this line is minus 1. So m1 equal to minus 1 and m2 is given by this. Okay. Now it is given the tangent is parallel to this line. So look at that, the diagram. This is your x plus 1 line. This is your x plus y equal to 0, and this is the tangent. This tangent is parallel to this line, so their slope must be equal. So look at that, I am equating the slope, and after equating the slope you are getting 1 by x minus 1 whole square equal to 1. So solving this you will get x1 equal to 0 and 2. There are 2 points, 0 and 2. Okay. So for x1 equal to 0, because as x1 y1 lies on this curve, as x1 equal to 0, it gives you y1 equal to minus 1, because y equal to 1 by x minus 1 is the equation of the curve, so it will give you y equal to minus 1, and if you substitute y equal to x1 equal to 2, it will give you 1. So there are 2 points you have 2 points. One is 0 comma minus 1, look at that, and another one is 2 comma 1. Why is it so? Because you look at that, the graph of y minus x1, y equal to 1 by x minus 1 has 2 branches, one in the first quadrant, another one this side. Okay, this is the graph portion and this is so there will be 2 tangents actually. This is one of the tangent and this is one of the tangent. Now you got the points, so easily you can find out the equation of the tangent by applying y minus y1 equal to m into x minus x1. So there will be 2 answers to this problem. So whenever there is a concept of parallel, that means you have to equate the slope of the tangent equal to the slope of the line, given line. So m1 equal to m2 gives you the points. So if you get the point, you can write the equation of the tangent. Okay. Next, just a short description. Tangent from an external point. So it is very easy to calculate because P is an external point. From that point you are drawing a tangent. So Q h comma fh is the point where you have drawn the tangent. So pq is the tangent, and this curve is also passing through, this tangent passes through AB, and these points can be found out by solving the equation of the tangent and the curve. You can find out this q point. Q point can be evaluated by solving these two. So this is called tangent from an external point. So you have an outside point. Suppose you have drawn a circle and you have an outside point. From that point you want to draw a tangent. So this is the tangent. So it is called tangent from an external point. Okay. Now let us have another problem, another way, because we have talked about the parallel lines. Let's talk about perpendicular. So find the points on the curve this, where the tangents perpendicular to the line this. So tangents are perpendicular to the line this. This is the given line. So first calculate the slope of the given line. So what is the slope of this line? Slope of this line is y equal to minus half. You can write y equal to minus half x. So m1 equal to minus half is the slope of the given line. And what is the points? You have to find out the points. What are the points? So in that case you need to find out the differentiation of this, derivative of this. So let's differentiate this. If you differentiate 8x plus 9y dy dx, so you know the dy dx value at x1 y1, suppose. So dy dx at x1 y1, you can easily verify that. That will be minus 4x1 by 9y1. Okay, and that is equal to m2, say. So these two are perpendicular. So tangent and this line are perpendicular. So m1 m2 must be minus 1, product of m1 m2 minus 1. And so because it's from the question, if it is parallel, then they m1 equal to m2, but if it is perpendicular, then it will be m1 into m2 equal to minus 1. So that will give you a relation between y1 and x1. So this is equal to y1 equal to minus 2x1 by 9. Okay, now this is relation 1. Now this x1 1 lies on the curve. Okay, now x1 y1 lies on the curve also. It satisfies the curve also, because this is an elliptic equation. So this is the ellipse and this is the tangent. So this is your x1 y1. So you see x1 y1 satisfies the curve as well as the tangent. x1 y1 satisfies the curve as well as the tangent. So you have 4x1 square plus 9y1 square equal to 1. This is the equation of the ellipse, and it is satisfied by this point x1 y1. So if you substitute y1 here, because you have another relation, this is the relation. If you replace your y1 by this value, then you will get x values, and you will solve the x for x, because your entire equation will be in x. In this way you can find out the points. Okay, so they want the points only. If you want the tangent, you can easily write the tangent equation y minus y1 equal to m into x minus x1. Okay, so this is the way how you will deal with the perpendicularity of the tangents, and perpendicular to the tangents, and parallel to the tangents. Tangents are parallel and tangents are perpendicular. Okay, let's now give one example of normal. Suppose this is the curve and x plus y equal to x to the power y. You look at that right hand side is a variable to the power variable, so you have to take log on both sides in this type of curve if you want to differentiation. So given curve is given by this, and where it cuts the x-axis, you have to find out the normal to the curve where it cuts the x-axis. And you know equation of the x-axis is y equal to 0, right? So if you substitute y equal to 0, you will get x equal to 1. So you got the point. You have the point. The point is 1 0. So you have to find out the normal to the curve at 1 comma 0. So now differentiation of this, we have to take log on both sides, and you know how to differentiate. You can get the value of the dy dx at 1 0. That will be minus 1, but normal will be, you know, minus 1 by dy dx, right? So be careful about that when you are writing the normal equation. So this is the value, this is the slope of the normal, and what is the equation of the normal? Y minus y1 equal to minus 1 by m. And what is your m? M is your dy dx at that point. into x minus x1. So if you substitute, you will get the equation of the normal. Okay, this is how you deal with the problems of tangents as well as with the normals. Let's now talk about angle of, what do you mean by angle of intersection of two curves? This is also very important concept. So what do you mean by angle of intersection of two curves, between two curves? So suppose you have a curve y equal to fx, another curve y equal to gx, function of x, function of gx. So the angle means the tangent, actually acute angle between the tangents. The curve intersection, angle of intersection of these curves. Suppose let me draw one curve. This is one of the curve and this is another curve. Okay, they have an intersection at this point. So what do you mean by the angle between the curves? The angle means the tangents. This is the tangent at the red curve and this is the tangent at the blue curve. So look at that, there is an acute angle between the tangents. So these angles are called the angle of intersection. Okay, so you need to find out the slope of the tangent at the first curve and slope of the tangent at the second curve. And if you know m1 and m2, how will you calculate the angle alpha between the two intersection? Tan alpha is modulus of m1 minus m2 by 1 plus m1 m2. So this is the result. This is the angle of intersection. Okay, got it? So angle of intersection of two curves means the angle between the tangents to the curve. Now if alpha equal to 0, m1 equal to m2, simple, because the curves will coincide and touch each other. And if alpha equal to 90 degree, pi by 2, m1 m2 equal to minus 1. So in that case we say the curve cut each other orthogonally. So this is very important. Orthogonality is very important. So if I say two curves cut each other orthogonally, that means the angle of intersection is pi by 2. They cut each other at right angles. Okay, let's have a problem on this. So you have an angle of intersection of two parabolas. Let's find out the angle of intersection of two parabolas. Y square equal to 4x and x square is equal to 4y. So let us draw the diagram first. It will be very good if you visualize the diagram. So this is y square is equal to 4x and blue one is the x square is equal to 4y. So this is your x square equal to 4y and this is your y square is equal to 4x. So easily you can find out the point of intersection. You look at that there are 2 points of intersection. One is the origin and another one is 4 4. You can easily calculate. How will you calculate that? Just replace your x. Replace your a. What is your x from the first equation? You can write from the first equation x equal to y square by 4. So replace this x in the second equation. So second equation can be written as y square by 4 whole square equal to 4y, and that give you fourth degree equation in y, right? Y to the power 4 equal to 64y. Okay, so that gives you y equal to 0 and y cube equal to 64. Okay, so y equal to 0 is one of the value. If you replace y equal to 0, that will be x equal to 0. So 0 0 is the one of the point of intersection, and y cube is equal to 64. That will give you y is equal to 4, but it must have 3 values. Why I am getting one value? Because other 2 values are complex. Other 2 values are complex and I am dealing with the real numbers. So real values, I want to see the real values on the curve. So this is y equal to 4. If it is y equal to 4, you can easily check that the other one will be x equal to 4. So these are the points. Clear? Now let us find out the slope. Let us find out the slope. So m1, that is the slope of the first one, is given by dy dx equal to 2 by y. Okay, and m2 is given by x by 2. Okay, so these are the values of m1 and m2. Now you see angle of, let us find out the angle of intersection at 0 0. Let us find out the angle of intersection at origin, because there are 2 points of intersection. So let us first visualize what will happen in angle of intersection at 0 0. So at if it is 0 0 at origin, you see m1 is infinity, m1 goes to infinity, the value of m is undefined, so it goes to infinity at 0 0, right? And what is the value of so what is the meaning of infinity? If the slope is infinite, that means the tangent to the curve is parallel to the x-axis, right? So if m1 goes to infinity, that means the slope of a straight line goes to infinity. That means tan 90 is infinity, right? That means in that case your tangent is, your straight line is parallel to y-axis. Your straight line is parallel to y-axis. So here we are talking about tangents. So tangent to the curve, let me write tangent to the curve, tangent to the curve, y square is equal to 4x, y square equal to 4x. What will happen? At origin is parallel to y-axis, parallel to y-axis, okay? So in this case your tangent to the curve is parallel to y-axis because you have a slope infinite, undefined, okay? Next, what will happen to the next one? If you substitute x equal to 0, it will be 0. So m2 is 0. The next slope is 0. So m2 is 0 means the tangent is parallel to x-axis. Let me write down the axis. So this is the curve. So if your tangent is parallel to x-axis, look at that, the dy dx is 0. This is the parallel to x-axis, so dy dx is 0. And if it is perpendicular, then this is tangent is parallel to y-axis and the slope is undefined. So in this case your tangent is parallel to x-axis, okay? This is the explanation. So what is the angle of intersection? So they must be at right angle. You look at that, their point of intersection, this is your point of, if this is the situation, then your angle will be 90 degree, no other possibility. So look at the diagram. Yes, you have a angle. If you draw the tangents, you look at that x-axis and y-axis at the tangents. If you see, they will intersect, their angle of intersection will be 90 degree. So in this case your angle of intersection is 90 degree. Is 90 degree or pi by 2, okay? So this is the concept how to deal with the angle of intersection, okay? Let us now find out the angle of intersection at 4 4. So let us now find out the angle of intersection at 4 4. So you have a point 4 4. So let us find out m1. What is your m1? You look at that, your m1 is 2 by y. So if you substitute, you will get m1 equal to half. And what is your m2? m2 is your x by 2. Look at that, your m2 is x by 2. So if you substitute 4, you will get 2. So if you find out the tan theta, what is the angle of intersection is given by tan theta? So m1 minus m2 by 1 plus m1 m2. In that way you will get the tan inverse. What you get the result? In this case you will get 3 by 4. So your result is angle of intersection is given by tan theta is equal to 3 by 4 or theta is equal to tan inverse 3 by 4. You can verify that. This is how you have to deal with the angle of intersection of two curves, okay? You can draw the graph. You have to find out the point of intersection by solving, and after that you find out by applying the formula tan theta, okay? So these are all about tangents and normal. Now let us go by case by according to our circle, parabola, all this. So let us illustrate this according to the circle, parabola, tangent and all that. So this topic is very important because equation of tangent to the circle, what will happen in the circle, in the parabola, and what is the condition of tangency? Let us find out. Okay, so let us take a very simple case of circle. X square plus y square is equal to a square. This is the circle. whose center is the origin, and whose radius is a. A is the radius of the circle. So how will you get the value of the, oh, and let us assume that y equal to mx plus c be the tangent. I want to find out the condition of tangency, and let us find out the equation of the tangent also. So this is equation 1 and this is equation 2. Okay, so how will you find out the equation of the tangent at x1 y1? So you will differentiate this equation. So if you differentiate number 1, you will get 2x plus 2y y1. y1 means dy dx. Let me write dy dx, otherwise you will confused with x1 y1 and y1. So dy dx equal to 0. So in that case you will get dy dx. You can take the parametric point also, or you can take the x1 y1. Okay, so dy dx at x1 y1 will be minus x by y, x1 y1. So what is the equation of the tangent? Y minus y1 equal to minus x1 by y1 into x minus x1. Right, this is the equation of the tangent to the circle at x1 y1. This is the equation of the tangent to the circle at x1 y1. So this is the point x1 y1, and you need to find out the tangent. So if you simplify, y y1 plus x x1 equal to x1 square plus y1 square, and x1 square y1 square also satisfies this because x1 y1 lies on the circle. You look at that, already we discussed that the point lies on the circle as well as on the point, so it must satisfy the equation of the circle. So you have x1 square plus y1 square equal to a square. So what is the equation of the tangent? It's very simple, x x1 plus y y1 equal to a square. So this represents the equation of the tangent to the circle at x1 y1. You can find out the equation of the circle at the parametric point. What is the parametric point of the circle? What is the parametric point of the circle? A cos theta comma a sin theta, because it satisfies the equation. This is the parametric. So what is the advantage of taking parametric point? Because if you take the parameter, you have only one unknown, that is theta. But if you take x1 y1, you have two unknowns, x1 y1. Okay, clear? So this is how you can write the equation of the tangent. So let me now find out the condition of tangency. So you see that the condition of tangency for circle is very simple. The perpendicular distance of the origin from the origin to the tangent is a. You look at that. If you draw a perpendicular from the origin to the tangent, it will give you the perpendicular distance. So perpendicular distance of the tangent from the center, that is the origin, is equal to the radius. So let us apply this, and this is the equation of the straight line, and this must be a tangent to the circle. We need to find out that condition. So let me draw one second here. This is the circle, this is the origin, 0 0 is the origin, and this is the tangent. This perpendicular distance is the radius. This is your y equal to mx plus c. So what is the perpendicular distance from the origin? 0 minus m minus c by root over 1 plus m square. That is the perpendicular formula, and that should be equal to the radius of the circle. So if you square both sides, sorry, this will be 0 into m, that will be 0. So if you square both sides, you will get a square into 1 plus m square, okay, equal to c square. This is the condition of tangency. You already learned this in your geometry part, maybe in very early stage you have learned this. This is your condition of tangency, a very important condition. Very simple. For circle it is very simple. We can find out, this is the way of finding without using anything, just a simple thing, that is the perpendicular distance equal to the radius, and that gives you the condition of tangency. So this line will be tangent to the circle if and only if this is the condition. So let me show you another way of finding that. That is also a very beautiful way. You can apply calculus here also, eliminating and all that you can apply, or otherwise let me show you another way. So this is the circle once again, and this is the line, this line and this line. There will be three possibilities actually. The circle may touch that straight line may touch the circle, the straight line may intersect the circle, or do not intersect. So these are the condition. So your circle is x square plus y square equal to a square, and y equal to mx plus c is the straight line. So I want to solve these two lines where it intersects. So in that case you have to unknown curves, you have to solve these two curves. So this is the point of intersection. You look at that. So let me find out the point of intersection. And this is also point of intersection if it is a chord. Okay, if it is a tangent, you have only one intersection, that is the roots are equal. So if you solve, let us substitute mx plus c whole square equal to a square. Okay, I am just replacing y by mx plus c. So you have a quadratic equation in x. What will be that? X square into 1 plus m square plus 2mcx plus c square minus a square. So this is the quadratic equation in x. Okay, and it must have equal roots, because you see, for a tangency, what is the condition? It must have two roots are equal, and for a chord, it must intersect at 2 points, but for a tangent it must touch the circle. So it must have two equal roots. And what is the condition for two equal roots? B square equal to 4ac. Okay, b square equal to 4ac. So what is your b square? B square is this portion, b is this, so 4m square c square, right? And 4, what is your a? 1 plus m square. Okay, and what is your c? C is your total, c square minus m square. This full is a constant. So if you simplify this, 4 cancel, and you see, if you expand this, m square c square cancelled, and you have c square into 1 plus m square. Okay, that result, sorry, not c square, that will be cancelled. C square equal to a square into 1 plus m square. You have the same result here. So this is another way of calculation without using any calculus. Okay, this is by using roots are equal. This is by geometrical concept, and this is also by geometrical concept, and this is by calculus. You can get the tangents, and you can eliminate. In this case, you can take the ratios of actually this is the tangent. Let us suppose this is the tangent, and according to the question this is the tangent. So let us compare them. This is another thing. If you want to use your calculus, so y1 plus x1 equal to a square. This is the tangent, and according to the question, y minus mx equal to c. This is the tangent. So if you compare, these two lines are identical because they are representing the tangent. So if these two lines are identical, the ratios of their coefficients will be equal. So x1 by minus m equal to a square by c. So from here you can get the value of y, you can get the value of x1, and if you substitute solving with the curve, you will get the value of x1 y1, and you will get the condition. Actually you will get the values of the condition in terms of MAC. So there are three methods in circle to find out the condition. And how to get the equation of the tangent? This is the way to get the equation of the tangent, by doing the differentiation and substituting the values. Okay, let me now discuss about parabola. what is the condition of tangency of the parabola and what is the equation of the tangent. So we take a simple equation of the parabola, that is the first form, y square is equal to 4ax. Let us take. And what is the parametric point? Let us take the parametric point in this case. So what is the parametric point of the parabola? Parametric point of the parabola is 80 square comma 280, right? This is the parametric point of the parabola, and y equal to mx plus c is the tangent. So we'll find out the condition later on. First try to find out the tangent at 80 square comma 280. So if you differentiate this y square is equal to 4x, what will happen? So 2y dy dx equal to 4a. So that is equal to dy dx at the parametric point 80 square comma 280, that is equal to, because you have 2a by y, so you have 1 by t is the slope. So 1 by t is the slope of the tangent to the parabola, 1 by t. So what is the equation of the tangent? Y minus 280 equal to m is your 1 by t into x minus 80 square, because you have taken a parametric point. So this is the equation of the tangent, and it will give you y equal to x by t plus 80. So this is the equation of the tangent to the parabola. Okay, at the parametric point 80 square comma 280 at this point. Okay, now this equation represents the tangent and this 2 also represents the tangents. So let us, these two lines will be identical. So if two lines are identical, their ratio of the coefficients of x and y and the constant term will be equal. So what is the coefficient of y? 1 1. And what is the coefficient of x in both the equation? Here you have a coefficient of x is m, and here you have the coefficient of x is 1 by t. So let us write m by 1 by t equal to, what is the coefficient in the constant? C by 80, right? So if you now simplify, you will have t equal to 1 by m, first two ratios, and if you take this one, you will get first and last. If you take first and last, you will get c equal to 80. So what you have? C equal to a by m by eliminating t. So this is the condition of tangency of a line y equal to mx to a parabola. So what is the condition of tangency? The condition of tangency of a line y equal to mx plus c to the parabola is c equal to a by m. In this case also you can apply the geometrical part. How? Because you can solve. So how will you solve? Y square equal to 4ax. So you can replace this y by y equal to mx plus c. So mx plus c whole square equal to 4ax. In this case also you can apply that this is a quadratic in x, second degree algebraic equation in x. It must have two zeros, and for a tangency the zeros must be equal, that is the roots must be equal. So roots, what is the condition for equality of roots? B square equal to 4ac. So if you apply b square equal to 4ac, then you will get the same condition. So this is the condition of tangency of a parabola, that y equal to mx plus c is a tangent to the parabola. Okay, clear all of you? And how to get the equation of the tangent? Let's now move to the ellipse. And what is the equation of the ellipse? Equation of the ellipse is x square by a square plus y square by b square equal to 1. Okay, and what is the parametric point? Parametric point for the ellipse is a cos theta comma b sin theta, because it will satisfy the equation. And what is the advantage of taking parametric points? Because you have only one unknown, theta. And what how will you get the equation of the tangent in this case? So if you differentiate this x1, not x1, sorry, x, so in this case you have 2x by a square plus 2y by b square. If you differentiate both sides, 2y dy dx equal to 0, so you have a dy dx as, what is your dy dx? Dy dx at that parametric point a cos theta comma b sin theta equal to, in this case if you substitute, you will get minus x by a square. So actually x by a square into b square by y. So if you replace these values, a cos theta, b sin theta, and if you substitute in the equation of the ellipse in the formula y minus y1 equal to m into x minus x1, you will get the equation of the tangent as this. This is the equation of the tangent. X by a sin theta plus y by b cos theta equal to 1. Okay, I have taken a cos theta, b sin theta, so this must be your cos theta sin theta equal to 1. And this is your tangent at x1 y1. And if you compare with y equal to mx plus c, this is also tangent to the curve. So again, like that, comparing these two, you will get the values of these two lines will be identical. So if they are identical, their coefficients of x and y, ratios of the coefficients of x and y will be equal. So in that case, you will get the value of cos theta and sin theta by equating the first two ratios and the first and the last ratios, and using that relation x square cos square theta plus sin square theta is equal to 1, you will get the condition of tangency as a square m square plus b square equal to c square. So this is the condition of tangency for a ellipse, that y equal to mx plus c is a tangent to the ellipse. This is the condition of tangency. And for a hyperbola, what you will get? For a hyperbola, it will be a square m square, it will be your a square m square minus b square for hyperbola. For this is for hyperbola. Let me point out that, sorry, so it will be for hyperbola. And you know that the hyperbola equation is here, you will have a minus here. The only changes is that you have a minus here. Okay, so this is how you will deal with different types of curves and parabola, ellipse, hyperbola, circle and all that. And I talked about the condition of tangency, which is very, very important. Let me now tell you a shortcut method to find out the tangent and normal for solving MCQ, or you can verify that your thing is correct or not. You can verify that, you can check that. So let us talk about a general equation. Ax square 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. This is called the general equation of second degree. This is called the general equation of second degree, right? This is a general equation of second degree. This is a second degree equation involving x and y. Okay, so what is the shortcut method to do the tangent? Suppose you want to find out the tangent at x1 y1, so you have to differentiate these and find out the dy dx at x1 y1. Then you need to substitute in the equation of the line y minus y1 equal to m into x1. So this is a very long process, but that is required for your board problems and all that. But if you want to do some shortcut techniques for MCQ and for JEE or other exams, so in that case you need to write, so if it is a square term, you need to write a product. So another square term is y square. So you need to write the product at x1 y1, y1, and here you have a product of x and y, and twice term will be halved. So you have a twice term, twice h, so it will be halved, and you have a product xy, so you need to write xy1 plus x1y in that way. Okay, so what will happen? Twice term will be halved, and the product xy will be written as xy1 plus x1y. Again you have a twice term, it will be half, and it's a single term x, so you need to write x plus x1. Okay, and another one 2fy, so you need to half it, so half y plus y1, because you have a single term y and the constant remain as constant. So this is the way of writing the tangent in a direct way. So you can verify your results in the exams also by this, that whether your equation of the tangent is correct or not, because if your equation of the tangent is wrong, whole calculation will be wrong. So let us apply in some methods. So let us apply the equation of the circle. What is the general equation of a circle? X square plus y square plus 2gx plus 2fy plus c equal to 0. This is the equation of the tangent. Let us apply that equation. This is the equation of the circle, general equation of the circle. Let us find out the tangent at x1 y1. How will you find out directly? I told you that square term will be x into product. So square term is product x into x1. I am going to find out the tangent equation of the tangent at x1 y1. So and the twice term will be half. So g of x plus x1 plus f into y plus y1 plus c. The constant term will be c. C will be remain as c. So this is the equation of the tangent. Okay, this is one. Let me show you more. Let us see that the simple equation. I have started with this equation of the circle. So let us apply at x1 y1. So what will happen? X1 plus y1 equal to a square. You apply your derivative rule, finding the slope and all that, or you will apply the geometrical rule. You will get this. So let us verify that this is correct or not. At the first page we got this. Let us go there and you verify x1 plus y1 equal to a square or not. Yes, I think it is okay in the circle page. Right. Yeah, this is the thing. Yeah, you look at that equation 1. This is same as what I have written over there. So this is the same thing. So this is the direct and this is by calculus. Okay, so now suppose you want to write the equation of the parabola directly. You want to verify your result in any calculation. So what is your equation of the parabola? Y square is equal to 4x. At what point you want to check? Let us check the at parametric point 80 square comma 280. So let us write it directly. So how will you write? Y into y1, because square term will be product. So y1 is 280 in this case. Look at that. And 4ax will be half. So 2a into x plus x, single term will be plus, so x plus x1 is 80 square. So this is the equation of the tangent. If you simplify, this 2a get cancelled, and if you simplify you will get the equation of the tangent, same as previously. You can verify for any type of curve. You can verify this result, the shortcut technique from anywhere, but don't try to try it for any broad question. Please do it in a manual way, like finding the derivative and finding by other methods, but you need to find out the slope in other problems, application of derivative. Let us now show you the equation of the normal. How will you write the equation of the normal directly? There is another formula, y minus y1 by normal. I am talking about a normal, equation of the normal. How will you write the equation of the normal? Fy, this is called partial derivative with respect to y. You might have used in the physics. So x minus x1 by fx, partial derivative with respect to x and partial derivative with respect to y. Partial derivative with respect to y and partial derivative with respect. So this is the formula for normal. This is a shortcut. You can check and verify. I am not going into detail of that. let me okay, let's show you one example. Suppose you have x square plus y square equal to a square. Let's start for the circle. So what is your partial, so this is your f, suppose your function of xy, this is your function of xy. Function of xy is x square plus y square minus a square. So what is your partial derivative with respect to x? Fx is 2x, the simple normal derivative. But when you are differentiating with respect to, because you have two variables, so when you are differentiating with respect to x, y is constant, and when we are differentiating with respect to y, x is constant, so it will be 2y. This is your partial derivative with respect to x, this is your, so at x1 y1, so let me write the equation of the normal. So y minus y1 by, I just look at that, fy at x1 y1, so it will be 2y1 and x minus x1 by 2x1. So if you simplify, you will get the equation of the normal. You will get the equation of the normal. Otherwise, you can solve like y minus y1 equal to minus 1 by m into x minus x1 in that way also. Okay. This is the way how you calculate the normal. This is the equation of the normal calculation, which is perpendicular to the tangent. In the last section today, let me talk about more what is the length of the tangent, length of the normal, length of the subtangent and subnormal at any point. So you see from the graph, let us explain the graph. This is the y equal to fx curve, and at P you have a tangent which intersect the x-axis at T. So PT is the tangent, and you look at that, PG is the normal which is perpendicular to the tangent, and you have another perpendicular that run from P to the x-axis, that is PM. So this angle is psi, this angle is psi, and you can easily verify that this angle is also psi. This is also psi. If this is psi, that is the tangent makes an angle with the x positive direction of the x-axis, that is slope is tan psi. So this is slope is tan psi. You look at that, slope is tan psi dy dx, and this is also psi. Okay, you can prove it geometrically. So what is the length of the tangent? Length of the tangent is given by TP. Length of the tangent is given by TP. And if you apply simple trigonometric relations, that is sin theta is perpendicular by hypotenuse, cos theta is base by hypotenuse, like this. So if you apply simple cos, so you will get, this is the form. The length of the tangent is given by mod y into root over 1 plus cot square psi, and cot psi is given by dx dy, because tan psi is dy dx, so cot psi is given by this. So this is the length of the tangent. So what is the length of the subtangent? Length of the subtangent is given by Tm. You look at that, this Tm is the length of the subtangent in the diagram. So that is also by trigonometric calculation, and that is by given by y mod dx dy, mod of y dx dy. And what is the length of the normal? Length of the normal is PG from P to the x-axis, from P to the x-axis, and that is also you can calculate by this relation, mod y root over 1 plus dy dx whole square. And what is the length of the subnormal? Mg is the length of the subnormal. Okay, so let me again summarize this concept. Let us draw a graph, and this is the P point. So if you draw the tangent at that point, this is the tangent, this is the tangent, suppose this is your P point, and this intersection, this PT is called the length of the tangent, and the perpendicular to the tangents, that is PG, is called the normal, and PG is the length of the normal. And again draw a perpendicular from P to the x-axis, this portion, this is called M, this is called subtangent, that is Tm is the subtangent and Mg is the subnormal. And these are the calculations of length of subtangent, length of subnormal, length of normal, length of tangent. So this is your whole scenario of tangent and normal. I think you go through this video and go through this concept of this pages, and how to calculate for different curves, circle, parabola, ellipse, hyperbola, and all that. And there are different conditions of tangency. These are very, very important for solving problems on tangent and normal. And also I have shown you the short technical, the very short trick, that is how will you find out the tangent and normal or verify the equation of the tangent and normal at your examination. So I stop here. Thank you all of you for your patience.